Okay, today we are going to look at section 5.3, moving into something a little bit different, looking at sum and difference formulas for cosine. Guys, I am trying to just hit the big picture stuff here, so if you look at your book, I am not covering every piece of this section. I'm just trying to give you a general overview. So the question I have for you, is it true if you have the cosine of two things added together, can you just distribute the cosine? In other words, if I said cosine of 30 degrees plus 60 degrees, is that the same as if I distributed this? So if you are a little bit rusty on these values, you know, your unit circle, your hand trick, you might need to pull your unit circle or one of those tables back out, refresh your hand trick. That's going to come in very handy in this section. So what I'm going to do is work both of these sides. On the left, you could do 30 plus 60, and we get 90. Using your hand trick, fold in your pinky. It's the square root of the bottom over 2, so square root of 0 over 2. Cosine of 90 is 0. On the right, cosine of 30. So if you fold in your index finger, cosine of 30 would be radical 3 over 2. Plus cosine of 60, fold in your ring finger, cosine of 60 is 1/2. Should be pretty obvious right now. You can't do a whole lot to add those together. You could make one fraction if you wanted. But regardless, that is not the same as the cosine of 0. So in general, if you have the trig function and in your angle, you have pieces added or subtracted, you cannot just distribute your trig function. So we are getting into sum and difference formulas now. Today I am only looking at the two cosine formulas. These are on your formula sheet under the sum and difference section. So pull that out, reference it as we go through. On every problem I work, I try to write out the formula as I use it so I can make sure that I'm doing it correctly. So if I want to evaluate cosine of two things added or subtracted, you have to use this whole formula to expand it. Alright, let's look at a problem. Let's say I asked you to find the cosine of 75 degrees. You could use the calculator and give me a decimal, but let's say I said exact value. Exact value means in terms of radicals. Well, 75 is not one of the angles that we learned on our unit circle. So we have to rewrite 75 using angles that we do know. So pull out one of your old circles if you need to. We need two angles that we know off our circle that either add or subtract to 75. Now, a lot of times there's more than one correct answer for this. I'm just going to use 30 degrees plus 45 degrees. That's what comes to my mind. Doesn't mean that's the only option. You could do 135 degrees minus 60 degrees, or different combinations like that. So there is not only one correct way to write it. So just find two angles that you recognize off our unit circle that either add or subtract to 75. So now I'm going to use my formula. We're adding, so I'm picking this formula. So it's cosine of the first, cosine of the second. So cosine of 30 times the cosine 45 degrees, looking at your formula, minus sine of the first, sine of the second. So minus sine of 30 degrees, sine of 45 degrees. Now it's a matter of your hand trick, unit circle if you need to. Remember, cosine is the x on the circle. So cosine of 30 is radical 3 over 2. Cosine 45 is radical 2 over 2. Sine of 30 is 1/2. sine of 45, radical 2 over 2. When you're multiplying, if the numbers are both under the radicals, you can multiply them together. We just multiply tops, multiply bottoms. So radical 6 over 4 minus radical 2 over 4. You can leave your answer like this. It does have a common denominator, so if you wrote it as one big fraction, that's fine. You can't actually subtract those radicals though, because it's different numbers under the radicals. So either of these two answers is correct. Okay, for B, this time I gave you something in radians. Now if you're like me, it is a lot harder to look at 17 pi over 12 and try to figure out two things that add or subtract to that. So what I recommend, if you're like me and you think better in degrees, go ahead and just convert this to degrees. Remember, you multiply by 180 over pi. So my pi's drop, so 17 over 12 times 180. And that's 255 degrees. Okay, so now looking at my circle, I need two things that add or subtract to 255. Again, not just one correct answer here. So find two angles that would work. Okay. I am going to do 225 plus 30. That's what came to my mind. But again, not the only option that you can use. So again, I'm adding, so I'm using the sum formula, so the first one. So that's cosine of the first.
No, Mom, is it okay if I don't talk to Mason?
Cosine of the second minus sine of the first, sine of the second. Okay, when I'm thinking 225, that's quadrant 3. Reference angle 45. In quadrant 3, cosine is negative. Cosine 45 is radical 2 over 2. Cosine of 30 is radical 3 over 2. Minus sine of 225. Again, 225 is quadrant 3, so sine is negative. Sine of 45 is radical 2 over 2. Sine of 30 is 1/2. So if we multiply, we get negative radical 6 over 4 minus a negative, so plus radical 2 over 4. Or you could rewrite this as negative radical 6 plus radical 2 over 4, or radical 2 minus radical 6 over 4. Any of those options are okay. Okay. For C, I gave you the other side of the formula. It's cosine times cosine plus sine times sine. I gave you this. So looking at my formula, that means it turns into cosine of A minus B. So this is the cosine of 173 minus 83. Simplify, 173 minus 83 is 90. Cosine of 90 is 0. So final answer there is 0. Okay. I just want to do a couple more problems using these formulas. So it's really just a matter of using the formula, which you have a formula sheet, you don't have to memorize them, but you do still have to know your unit circle values, or your hand trick there. This time I'm giving you a proof, so that's like what we have been doing. Box in your easier side, so that would be your cosine x. So I'm going to work with the left. I have cosine of a plus b, so that's cosine of the first, cosine of the second, minus sine of the first, sine of the second. Okay, so cosine x, I don't know what that's equal to, but cosine of 2 pi, that's 2 pi is the same as 0. Cosine of 0 is 1. Minus sine x, sine of 2 pi, that's like sine of 0, which is 0. Cosine x times 1 would just be cosine x. Sine x times 0 is 0. So we get cosine x as we want. Okay. Last problem I want to do. If I asked you to write this as a single cosine, it's cosine times cosine minus sine times sine. So if you look at your formulas, the minus one means we're doing the cosine sum. So that's cosine of a plus b. 3x plus 2x is 5x. So this simplifies into cosine of 5x. Right, this was a pretty short lesson. I'm going to give you guys just a few practice problems. Please send this to me. Hopefully this is working okay for you guys. If you have any issues with it, let me know. I do like to see your work, and I want more than just your final answer. I like being able to look through the work that you did to catch any mistakes and let you know about that. So if this method isn't working well for you, let me know. But otherwise, I think I'm going to continue how we have been working. So I have just 8 problems today, some of them are true or false, and as